Okay, I actually started recording, so let's get started. Yay, we only have 3 people. So, okay, cool.
You'll learn though.
Okay, so actually today I'm going to go by order because I'm recording, so I'll start from question 1. Question 1, part A, given some sample space omega 1, 2, 3 and events A, 1, 2 and B equal to 1, then probability of B given A is a half. This is false because we do not know whether the sample space is uniform or not. If we do know, we will be able to do something like size of A, and the denominator would be the size of B intersect A. However, this doesn't work here because it's not uniform. Okay, cool. Also, by the way, there are midterms in the front if you guys ever need them. Just, do you guys need to look at them? Okay, cool. Actually.
Thank you. Just monopolizing all the activities. I'll get an extra one.
Okay, and now for question B, it's the same. So not uniform. So you can like do it just by counting the size of the sample space. So false. Okay, cert 1, linearity of expectation applies if and only if the random variables involved are independent. The only if part is false because you can also use linearity of expectation when the random variables are not independent. Okay, so part D, the variance of a random variable that only attains value in the interval -1 to 1 is at most 1. Well, there's a more complicated proof, somewhat formal, but the intuition behind this is that variance is the largest when the random variable's values are most spread out, right? So most spread out in this case would be you take on 2 values, one at -1 and one at 1. Okay, and each with probability a half. And at this time, the variance of x is equal to 1. So, and in each other cases, the variance could be no greater than 1. Yes. Okay, for part E, if 2 events are disjoint, they're independent. Well, this is not very true, right? Because, let's see, if probability of event A is 0.1 and the probability of event B is 0.1 and they are disjoint. Now we look at the probability that A intersect B is actually 0 because they're disjoint. However, if they're independent, it should be 0.1 to the power of 2, right? So actually in this case, A and B are not independent. Okay. For part F, if 2 events are independent, they're disjoint. Well, this is also not very true. Think about this case. Probability of A still equal to 0.1, B still equal to 0.1, okay? And they are actually independent. So if they're actually independent, probability of A intersect B should be probability of A times probability of B. So which should be 0.1 to the power of 2. So it's not equal to 0. So these 2 are not disjoint. So this statement is false. Okay. For part G, the value of V, which maximizes the probability density function of a continuous random variable, is equal to E of x. Okay, if we look at the exponential distribution, something like this, PDF of exponential lambda. Okay, the greatest value of PDF is actually achieved at 0.0, right, when x equal to 0. However, the expectation of x is achieved when x equal to 1 over lambda. So this is actually smaller than the value at x equal to 0, so the statement is not true. Okay, so for part H, we actually end up not looking at this question because this question, well, we need to see this is a finite Markov chain. But we didn't really specify that, so that makes it hard to grade because For finite Markov chain, it is absolutely true that it always has a stationary distribution, but that's not true for infinite Markov chain, so it's not really well worded, so we drop this question.
Is it possible to pause the recording? Just asking.